So exciting. There we go. All right. So on this sheet, there are a few things that I want to just define for you. Make sure you feel good about it. Um, you have the revenue function. And these will actually tie into, even though I'm changing up what we're doing. So the revenue function, they call it R at X. R at X is a fancy way of writing Y. And that's equal to P at X plus C at X. And P at X is, let's see, what is P at X? That's just your price, like your sale or whatever. And then here's the cost. And the cost is, how much it would to make it. Okay, so like if you, let's say you're manufacturing something and you're selling for $20, but it also costs you, $3 to make it with all the parts you put together. So that's kind of where that goes. Okay, so revenue is, price per unit times the number of units as well. That's another way to look at it. Okay, that's not hashtag units, that's number. Okay, and then there is the cost function. That's going to be cost is equal to VC plus FC. So let's figure out what those mean. So let's see. I have it written down someplace else. I have to look at it real quick. No, I don't have it there. Where do I have it? VC, FC. Oh, so this would be like some sort of fixed cost. Those are things that if you had a company, you have to pay every month. Your electric bill, your employee wages, your water bill, your rent on your building or mortgage on your building, whatever. And then VC is the VC is what? I forgot. A variable cost. So that's the number of units produced. Variable cost. So cost. Okay. Good so far? All right. So with that information, then we start talking about fixed costs, which we already said. So that's kind of like your rent, your water, your wages, whatever every month will be, you have, that's going to be a part of it. Your variable cost, that's your number of units produced. And then usually that we would have an X right there, and X would be how much your selling point would be for that particular item. Okay? Everything kind of makes sense so far? Again, these are definitions that we will definitely be going back to, but we have a kind of a different order of stuff that we're going to be doing. All right? Spitting out your chew. Your Copenhagen. There was one time, it wasn't here, it was when I was at Chaparral. Somebody was chewing tobacco and they put their remnants of their dip in the water fountain, and I saw it on the walker back in, and a girl goes walking out, and I said, "What do you go spit out your chew?" She goes, "No, I already spit it out." I'm like, dude, funny stuff. Yeah, I'm just like, holy cow. All right, so then we have the marginal revenue. They call it MR. This is going to be basically the slope of the revenue function. Okay, being that you're going to be using y equals mx plus b in some format, the slope is here. The marginal cost would also be a slope. So you're creating multiple linear equations. And then your marginal profits, this would be your slope of your profit function. Okay? So, everything seems so far? Oh, I did. Sorry about that. What did I skip over? Oh, the profit function?
Sorry.
That's okay. Profit function is this. They call it P at X. It means the same thing as Y. Is R at X minus C at X. So you take the revenue minus the cost, and that's how you figure out your profit. Okay, now a lot of times when you're dealing with business, you want to find out your break-even point, which means the same amount of money that you're putting in as you're getting out. And I know people will say, well, why don't I want to know that? You don't want to just take a shot in the dark of, yeah, I think we're going to sell 200,000 of these items. And then you order all this stuff and you sell 12 of them. And now you're sitting there going, well, shoot, that didn't work out the way we wanted it to. Kind of happens that way. But there are some things that companies do, and we kind of get the benefits of this. But I know you all have probably hit like an outlet store at some point, whether you go down to Castle Rock or, up there in north of Denver. There are those outlet stores in which you can buy items for a lesser amount of money. Those items weren't necessarily that season's items. It might have been last season's, it might have been last year's items, but they're still new to you because they haven't been worn or used. The reason why they've created those outlet stores is it's cheaper for a company to take a slight loss. Let's say you go into the Ralph Lauren store, the Polo store, or whatever store you're going to choose. And let's say you're going to buy a shirt, but you saw that shirt at Dillard's like a year ago, and let's say that shirt at Dillard's costs $100, but you go to the outlet store and you can get it for $30. Well, the company might be into that shirt for $25, so they're going to make $5 profit versus if it was at Dillard's, they would have made a bigger profit. But rather than the store taking back merchandise that has not been sold and putting it in a warehouse to think about, they're going to put it in the outlet store. And the reason why they're going to put it in the outlet store is if you take it, let's say you have some warehouse for your company that you're storing things that haven't been sold, the federal government and the state government tax the company on unsold merchandise. So they're going to have to pay a tax on stuff to sit in a warehouse, which is crazy. So the manufacturers or those stores are more willing to sell it at a lower rate, even if it is maybe a slight loss to the company. They're willing to get rid of that, move the product, than keep it. So let's say Ralph Lauren gave Polo, let's say a red Polo shirt in all different sizes, and Dillard's is supposed to sell those. Okay, so Dillard's is going to sell, let's say they sell half of them. So there's still 50 of them that haven't been sold. For whatever reason, people just didn't want to buy it. Well, Dillard's will play around with it a little bit going, oh, you know what, a bunch of smalls sold up here in Fort Collins. So send the, Dillard's in Denver, send up your smalls from up to Fort Collins, see if we can sell them. They'll see if they can sell them. If they don't sell them, they're going to ship them to a warehouse. The warehouse is going to say, okay, we have, say, 20 smalls left, we have 30 mediums, and we have 30 larges. Okay, we're going to take all those, we're going to put those in our outlet stores, which, yes, they still have to pay the rent on, they still have to pay the employees on, they have to pay the shipping cost. Usually it's their own company, if it's a large enough company that is doing the shipping. So then they will put it at that outlet store. That outlet store will then hold on to those items, try and sell them. If they don't sell them, they have a couple of choices to do. The outlet stores then have secondary outlet stores, which we know of as Marshall's and Ross and stores like that. So it's basically how the stores are trying to dump their merchandise as fast as possible. And even though they might take a loss on it, if you were to say have a shirt that you're invested $10 in on, and you're able to still make $8, so you're taking a $2 loss, it's better than taking a $10 loss. So that's kind of the thought process that's been taking place with, um, in the sales world. All right. Let's see. Let's see. It says down here, so suppose the cost in dollars for a product goes along with this equation. C equals 21.75x plus 48.90. What is the marginal cost for this product? Okay, so the marginal cost for this product is our slope. Okay, it's the slope of this. So it's 21.75 per item. Okay, what does the 48.90 stand for? That stands for how much it costs to be in the store, pay the rent, pay our employees. So those are things. So obviously you're trying to get a break-even point for that, which is great. But you'd have to sell a lot of these to make up for that. Okay. And obviously, if you're only selling one item out of your store, I don't know how successful your store is going to do. That's why when you walk into a store, there's a lot of items. Okay. So it says down below, it says, suppose you sell 1,000 widgets. I'm going to sell 1,000 widgets. I don't know what a widget is, but we're just going to call it. And the company makes $15,500 selling that many widgets. But then they realize that another store sold 1,800 of them. And that other store makes this much, exact same item. So you basically have now created yourself 2 points. So you have 1,000, comma 15,500, and you have 1,800, comma 2,790, or 900, excuse me. We know that we want to find the slope. So I get x1, y1, x2, y2. And we're going to go with it. 2,790 minus 15,500 over 1,800 minus 1,000. So I'll bust out a calculator just because I can. Clear. 27900 minus 15,500. That gives me 24,400 on top, divided by 800 because 1,800 minus 1,000. So I'm going to divide that by 800. And this comes out to 15.5. So that's now my slope. Once you find your slope, you can use your point slope equation, and it doesn't matter which y minus y1 equals the slope, x minus x1. Pick one of your sets of points. I'll pick this one. So I'm going to get y minus 15,500 equals slope, which is 15.5, and then x minus 1,000. So you're going to get y 15,500. Distribute that over, so I'm going to get 15.5x minus 15500. Add that to both sides, so you wind up with your equation to this being, and this is going to be your equation. So write an equation for your revenue. This would be for your revenue. Okay, 15.5 times however many items you sell. Okay, revenue incorporates everything into it that your item should sell. It doesn't show you a profit, it just shows you a revenue, what you're taking in. Just because, let's say, King Soopers, let's say they take in $100,000 on a Saturday selling groceries. Any one particular, I could be rounding up, rounding down, I'm just picking an arbitrary number. That they didn't make, their revenue was $100,000. That was great. But then there's things you have to take away. You have to take away all of the other items that would have went in for the Saturday. Saturday was a really cold day, so to heat the building costs a certain amount of money. So that is money that gets taken away from $100,000. All the employees in there, what they make, that gets taken away from there. The water for the building, that takes away from the $100,000 for that day. The rent on the building, that takes away from that. So even though the store brought in $100,000, they might only make $2,000 or $3,000 profit that day. Now, some people might say, "Oh, the store's only making $2,000 or $3,000 profit." Well, how many King Supers do you know of? If they're all making that, that company, let's say there's 1,000 King Super stores and you're making $2,000 on a Saturday, that's a lot of money that that corporation's making just on one day. So it's kind of the ins and outs of some business. So suppose the profit function for a product is linear. Okay, so it's y equals mx plus b, and the marginal cost is $5. If the profit is $200 when 125 units are sold, write an equation for the cost function. Okay, so we said up above that marginal cost is the slope. And they tell us the marginal cost is $5. So that's going to be the slope that we're going to deal with for our problem. And then it says, hey, what if the profit is 200,000 when 125 units are sold? So you're going to make a linear equation. So that's x1, y1. We have our slope. So you can just go back to your slope equation from algebra 1, or your point slope equation. Y minus 200,000. One more. And then x minus 125. And you could make this a pretty simple linear equation. So 5 times 125. And then add 200,000 to that. So this is going to be y equals 5x plus 200,625. So that right there would give us the cost function. Bless you, my friend. That gives me a cost function to that. Seem okay so far? Makes sense? Anything wackadoodle? All right, I am on the back of the front page. All right, so there is the graphing approach, so you can graph, see where they intersect, or you can just do it the algebraic way, and they're both fine, it doesn't matter. So they tell you that a manufacturer sells widgets for $10, and they find that their costs, so this is what they sell it for, and they tell us that we have fixed costs of $1,200 a month. So that's your rent, that's your water, whatever. And the variable cost are $2.50 per unit. Okay. How many units must a manufacturer produce to break even? Okay. So if we're going to sell things, this is going to be our revenue. That's our revenue equation. Okay. For each item I sell, 10 bucks. I sell 10 items, 100 bucks. And then I have my fixed cost and my variable cost. So this is going to create another equation, which is going to be our cost equation. So our variable cost is $2.50. That's our slope for this equation. And then our fixed cost is $1,200. So now, if I wanted to figure out the break-even place, I could do this. I have to realize R at x is the same thing as y equals 10x. I have to realize that C at x is also y equals 2.50x plus 1,200. I could go ahead and try and graph them and figure out where they intercept, or I could just take this and this and set them equal to each other. Subtract 250. And divide 1,200 by 7.5. So that's going to give me 160. So I need to sell 160 of whatever I'm selling to break even. Okay, so how am I going to figure out what my Y value should be? Well, I'm going to take that Y value, I'm going to either plug it in here or I'm going to plug it in here. One of those equations looks simpler to use. It's the same answer. I'd say this is a simpler one to use, so I'm going to go Y equals 10 times 160, and that's going to be 1600. So if I sell 160 widgets, trinkets, whatever it is, then I make $1,600, and that is my break-even amount. If I sell 161, I make profit. If I sell 159, I'm in a loss. Seem okay? So the other example down below, they talk about a company can sell 50 widgets of revenue of $2,000 and 150 widgets for $6,000 of revenue. The total cost equation is given by that, where X is the number of units. So we have two items that we have to use. I don't think that's going to be right. Let me see. 400. Nope, good. All right. So the very last example I'm going to look at is if I sell 50 widgets for 2,000 and I sell 150 of them for 6,000. So we need to figure out the equation this makes. And then they give us this cost equation down here that we're going to use in a moment. And that's just a given equation. So if we find the linear equation here, I'm going to find the slope. So I'm going to go 6,000 minus 2,000. And 150 minus 50 equals 4,000 over 100. So I get this to be 40. So I get a slope of 40 on this one. I'm going to use my point slope equation. It doesn't matter which point I pick, it's going to be the same equation once I solve it for y. So I'm going to have y minus 2,000 equals 40, x minus 50. So minus 2,000 equals 40x minus 2,000. If I add 2,000 to both sides, the 2,000s cancel out, so I get y equals 40x. So if I want to find my break even, I have one equation. I have to realize this is also this equation. So if I want to figure out my break even, I'm going to set those two equal to each other. So I get 40x equals 10x plus 18,000. Gives me 30x equals 18,000. Knock off a 0. So 3 goes into that. That'd be 600. So if I sell 600, then if I take that 600 and I plug it in here or here, it's going to give me the same answer. If I plug 600 in here, that's going to give me this, which is going to be 24,000. So
That's a 50x, right? 50x equals 18,000. Right under the 40x equals 10x.
oh, I subtracted 10x,
Oh, okay,
so then it'd be a 30x. Sorry about that. So if I sell 600 items, I make $24,000. That's my break even for this particular situation. Okay? So I would like you to work on where it says worksheet 2.1. I think I did 1, 2, and 3. And that's what I got. Then on Monday, we'll go over those 3 problems. I'll give you points for them. And then I'm changing directions. I don't have necessarily notes for you, so like you're welcome to snag that paper for notes if you want that. But I think you're gonna like what we're gonna head towards. And it was just weird because I'm sitting there. I had gotten done with this lesson yesterday, and I started to thumb through the book, going, I don't like where this is going. And I thought, I'm going to change it. I'm going to change it for the better, and it's going to be the better for y'all. We're going to use a lot of stuff on the calculators. Don't worry. Like, when we're working with the calculators, especially when we're working with the calculators, we are doing it as a group, okay, even on the tests. So don't be like, oh my gosh, what button do I push? I think collectively, you all as a group would be able to figure out which buttons to push and stuff like that. Sound like a plan? And then hopefully your senioritis doesn't kick in too badly. Since March 20th of last year.
Please, since August 11th, 2018.
Wow.
That's crazy. I remember that.
Well, I do hope that I am one that you might remember at some point. What happened?
2018, 2017, that was 2017. So August 11th, 2017.
It's like I'm out of this place.
I don't know why I walked in. I just got